Hello learners, my name is Mrs. from College, Westwood. I am your teacher for advanced level pure mathematics. We are still on complex number 1. And before we go deep into our lesson, let's do a recap of what we did when we met last time. We talked about modulus and argument of a complex number. When you are calculating the modulus, you are given a formula that you should follow. Let's say you are given two complex numbers that are multiplying each other, and you are told to calculate the modulus and argument. How do you go about it? You first calculate the modulus of each complex number. After getting the result, that's when you will multiply. The same applies when you are dividing. What do? You calculate the modulus of the numerator, you calculate the modulus of the denominator. After getting those answers, you divide. Okay, let's go into today's lesson. Our objectives for the day, we have to express a complex number in polar form or trigonometrical form. Then we have to find the square root of a complex number. We will start by looking at polar form or trigonometrical form. I am going to draw an arc diagram, and we want to derive the trigonometrical complex or the polar form using that diagram. This one, it's our y-axis, which is the imaginary, and this one, it's our x-axis, which represents the real. We have a point P here, which has coordinates x and y, and we have this one as our r and our angle here. Alright, we have point P, which has coordinates x and y, and r, which is our modulus. How do we calculate r? R is given by r squared is equals to x squared plus y squared. R is equals to square root of x squared plus y squared. It is believed that in trigonometrical ratios, x is equals to r cos theta, and y is equals to r I sine theta. Alright, our complex is denoted by z is equals to x plus yi. So we have to substitute the values for x and y in our complex formula. For x, we will write r cos theta plus for y r I sine theta. When we factor out r, let's factor out r. What will you have? We have cos theta plus I sine theta. This one becomes our trigonometrical form or our polar form, where r is the modulus. And how do we calculate this modulus? Is square root of x squared plus y squared. And theta is the argument. And we have already said that argument is found by arctan y over x. And remember, when you are calculating, your answers should be in radians. Okay, let's look at examples. Okay, I will write the examples on the board. Express the following complex numbers in trigonometric form. Okay, we have A 1 plus I, B minus 1 plus square root of 3I. Let's first look at this one. I'll give you more. Okay, we want to express it in trigonometrical form, and that form is r cos theta plus I sin theta. And we have already said that r is the modulus. So for us to fulfill this, we have to calculate the modulus first and the argument. What's our modulus? R is equals to square root of 1 squared plus 1 squared. And what's the answer there? It's square root of 2. That's our answer. Then for our argument, which is theta, is what? Arctan 1 over 1. Like yesterday, I taught you how to use a calculator. You will say second function tan, then it will be arctan. You put in bracket 1 divided by 1. What do you get? You can start by putting this in degrees so that it will be easier for you to convert from degrees to radians. If I put this in degrees, it's 45 degrees. But most questions we want you to put them in what? In radians. So how do you go about it? You divide your answer with 180. And when you do that, you get pi over 4. That's 45 into 45, 1. 45 into 180, that's 4. Now we have our r as square root of 2. And our theta is pi over 4. And we then substitute these values, these two values, into our trigonometrical form. And our final answer, I'll put it in another ink so that you can see. Our final answer will be square root of 2 cos theta plus I. Sorry, for theta there, let me restart. It will be for r, that's square root of 2 cos. For theta now, we write pi over 4 plus I sine. For theta again, we write pi over 4. Alright, I have left out a stage that is very crucial. When you are calculating theta, first make a diagram so that you identify if your theta is positive or negative. For this one, let me just go back. For this one, the diagram is like this. This is z is equals to 1 plus I. Is in the first quadrant, so our answer will be positive. Okay, let's move forward. Let's look at the other question. I gave you minus 1 plus square root of 3I, and we have to write this in trigonometrical form. The procedures are the same. The first thing is to write our r, or to find our r. R now is equals to square root of minus 1 plus square root of minus 1 squared plus square root of 3 squared. Square root of 3 squared, how do we solve that? We will say it's like you are expanding. So it will be square root of 3 squared, which is square root of 3 times square root of 3. If we put this under one square root sign, we will have square root of 3 times 3, which is square root of 9. And square root of 9 is what? Is 3. Alright, our r in this case will be 2. And our theta, we draw an Argand diagram. Z is equals to minus 1 plus 3I. it falls in the second quadrant, which means our answer should be positive as well. So when we calculate theta, we get minus 60 in degrees. But as we have already said that it should be positive, what do? We add pi. In degrees, pi is equals to 180 degrees. So when I add plus 180 here, I get 120. I have to change this 120 to radians. I divide by 180. Then it becomes 2 over 3 pi. I then substitute this value for r and theta in my equation. Let's take a short break and we'll be back soon. Welcome back, learners. Let's look at more examples on complex numbers. Alright. Express the following numbers in trigonometric ratio. We have we want to express 1 minus square root of 3i in trigonometrical form. The first step that we do is to find the modulus, which is r. r is equals to square root of 1 squared plus minus 3 plus square root of minus 3 squared. And when we calculate this, we'll get our square root, our r is 2. Then we move on to calculate theta, which is given by arctan minus 3 square root of 3 over 1. Our theta is given by arctan of minus 3 over 1. What do? You use your calculator. You punch your calculator. I will teach you on how to punch your calculator in degrees, then changes to radians. Because when you are dealing with the trigonometrical ratios, the answers have to be in radians. So let's start by putting our calculator to degrees. When it's in degrees, it will be written DEG. So you say second function tan square root of minus 3 divided by 1. The answer that you get there is minus 60. Is minus 60 degrees. And you have to find if this answer falls in the first, second, or third quadrant. What do? You draw. And when you draw, your answer falls in the what? In the fourth quadrant. And we have already alluded that when it falls in the fourth quadrant, we leave our answer as it is. So what we do here, we divide by 180 degrees. And our answer will be theta is equals to minus pi over 3. Then, when we are done, we now substitute the value of r is equals to 2 and the value of theta is equals to minus pi over 3 into our trigonometrical ratio. And this becomes 2 cos minus pi over 3 plus I sine minus pi over 3. But we are told that in trigonometrical ratios, cos minus theta is the same as cos theta. And sine minus theta is the same as minus sine theta. So let's rewrite this considering this one. So our final answer will be 2 cos. Where there is a negative there, we put a positive and it becomes pi over 3 minus I sine pi over 3. That's our final answer. Okay, let's look at another example there. the complex number (7 plus 3i over 5 minus 2i) and show that its argument is pi over 4. Hence, express z is equals to 7 plus 3i over 5 minus 2i in polar form. This question is asking us to find the argument and express it in radians, as well as to express it in what? In polar form. Okay, let's look at the solution. We say let z is equals to 7 plus 3i over 5 minus 2i. What do we do here? We multiply the denominator and the numerator with the conjugate of 5 minus 2i. The conjugate of 5 minus 2i is 5 plus 2i. So I'll multiply both the denominator and the numerator with the conjugate. Here we do expansion of brackets, which is 7, 5 plus 2i plus 3i bracket 5 plus 2i. For the denominator it will be 5 plus 2i minus 2i 5 plus 2i. And when you simplify this, you will get 35 plus 14i plus 15i plus 6i squared. This is 25 plus 10i minus 10i minus 4i squared. And it is believed that I squared is equals to minus 1. So when there is I squared, we put minus 1. And when we simplify this further, we will get 29 plus 29i all over 29. And when we divide, we get 1 plus I. Okay, learners, let's take a short break and we will be back. Welcome back, learners. Let's continue answering part 2. We are now on answering the modulus. The modulus, how do we find the modulus? The modulus is equals to square root of 1 squared plus 1 squared. And when we simplify this, we get square root of 2. We now move on to find the argument. The argument is given by arctan 1 over 1. And before we move on further, we have to draw a diagram and locate where our argument will be. It will be in the first quadrant, which means our argument will be positive. And when we calculate this one, I said you should start by converting it to degrees. When you calculate this, you get 45 degrees. Then you convert 45 degrees to radians, you divide by 180, and your answer will be pi over 4. The question further asks us to put this in polar form. What are we doing? We are just substituting the value of r as square root of 2 and the value of theta as pi over 4 into our trigonometric or polar form. So for r, it will be, let me put a difference in there. For r, it will be square root of 2 bracket cos. For theta, it's pi over 4 plus I. For theta again, it will be pi over 4. We have answered the question. Alright, we are now moving on to a subtopic, square root of a complex number. Square root of a complex number. That's our subtopic. Square root of a complex number. It is believed that z squared is equals to x plus yi. We are going to use this one to find the square root of complex numbers. Let's look at an example so that we can explain how we can use this one. We have to find the square root of minus 5 plus 2i. We have to find the square root of minus 5 plus 2i. How do we go about it? There are some stages that we should follow. The first stage, we are given that z squared is equal to x plus yi. So we are going to say x plus yi squared is equal to minus 5 plus 2i. We have to square this. So how do we do that? We expand the brackets. It's like we are saying x plus yi is also equal to minus 5 plus 2i. When we expand the brackets, what do we get? We get x squared plus xyi plus xyi plus y squared I squared, which is also equal to minus 5 plus 2i. When it is also believed that I squared is equal to minus. So when we multiply y squared with minus 1, we get x squared plus 2xyi minus y squared is equal to minus 5 plus 2i. Alright. After this stage, we now want to equate real numbers and imaginary numbers to form simultaneous equations. On this side, our real number we have x squared minus y squared is equals to minus 5. We say this is our equation 1. Then for the imaginary, we have 2xy is equals to 12. So there should be 12 here. Is equals to 12. This becomes equation 2. What do we do? We are going to use the method of substitution to solve this simultaneous equation. How do we go about it? We choose any equation and make one letter the subject of formula. So I will choose equation number 2 and make y the subject of formula, and it will be y is equals to 12 over 2x. When I further simplify this, I'll get 6 over x, and this becomes my equation what? My equation 3. I then substitute the value that I get into equation 1, and it will be like x squared minus 4y. I write 6 over x squared is equals to minus 5. Then I multiply, I distribute my squared to both 6 and x, and it becomes x squared minus 36 over x squared is equals to minus 5. Alright, let's move on to another page. It will become x squared minus 36 over x squared is equals to minus 5. And when you simplify this, you get x to the power 4 minus 36 is equals to minus 5x squared. We have x to the power 4 plus 5x minus 36 is equals to 0. This is an example of a disguised equation, and when we calculate this, we are going to get x squared plus 9 x squared minus 4 is equals to 0. So we say either x squared plus 9 is equals to 0 or x squared minus 4 is equals to 0. When we simplify this, we'll get x squared is equals to minus 9. This one has no real root, so we don't use this one. We now use x squared is equals to 4, which has the values plus or minus 2 when you simplify. Then what do? We now use these two values and put them in any of the equations that we want to find the values of I. When I substitute, when x is equals to plus 2, and I substitute that in that equation, I will get y is equals to 3. And when I substitute minus 2, I will get y is equals to minus 3. So the roots will be 2 plus 3i and minus 2 plus minus 3i. Alright, I'll leave you with a question that you have to do so that you assess yourself if you have understood complex number 1.